let's just pray and hope that all things works out well so we can cover this aspect of our lesson today. Right. So last class we're talking about density. Did anybody do any read up in regards to what we're talking about? I'm talking to the class. Rashida, are you there? Rihanna.
Sir?
Yeah, I'm talking to you. You know that, right? Rihanna, are you there?
Yes, sir.
Yeah, I asked a question just now. Can you answer the question?
Sir, which one? Are you talking about the read up on density or why things sink or float?
Read up on density or what? Yeah, both of them. You can go ahead and answer any one you want to answer.
So, the density of a substance is its mass per unit volume, and objects with tightly packed molecules are more dense than those where the molecules are spread out. Density plays a part in why some things float and some things sink. Objects that are more dense than water sink and those less dense float. When an object floats, it pushes water out of the way, which is called displacement.
All right, all right. Nice, nice. So that's your research?
Yes, sir.
Wonderful. I hope other persons did that, right? As you can see, there are persons here who actually did their assignment. And pretty much I believe you understand what is density now, right? From your reading up, I believe that you have a good understanding of what it is. I would assume. Because it doesn't make sense you would write something and you don't understand. Volume here is I would say 102 liters. All right. Now the mass of my block here, which is a piece of wood, right? Let me see if I can. I'm not sure if I can see the value of the density, but clearly we can see that the piece of block is floating on the surface of the water. Can we see that?
Yes,
Yeah.
sir.
Good. So this is just going to tell me that the water is more dense because it's not sinking, which means that the upthrust force here is much greater than the weight of the object that is acting down, right? Because remember, once the upthrust force is greater, right? It's going to tend to push back the object up on the surface of the water. Now, if I'm supposed to change this now to a different object, so to speak, let's try styrofoam. Now we know that styrofoam is banned in our country now, hopefully, right? So styrofoam is less dense because we realize that the mass here, decrease when you compare it to the mass of the block, and we can agree with that. Styrofoam is very light. So in addition to that, guys, when you look at the volume, the value for the volume just changed a while ago, which goes to show that less of the water was displaced. All right, and that is as a result of the lightness of that particular material. Right now, imagine now I placed a brick inside of the water. Right, the brick is going to sink because the particles are more compact, right? Hence, now you're going to have a greater density of that object going against the density of water, because water is classified as an object, and it is within inside of a container, so we can say yes, it's going to have density, right? Now, guys, the value for the density value, guys, it's constant. It doesn't change, and it is the same thing for other materials. So if the density of water is 1 grams per centimeters cube, no matter where you go in the world, that will remain the same. It will not change, right? The same thing as it goes on to, and I must say this, it doesn't matter the value, the volume of water, right? It should match back out to be the same. So if I had 10 grams of water, right, inside of a, we call it, a 10 centimeter cube container, right? Whenever I do my mathematics to find the density, I'm coming to your iPhone, right? I expect that the density is going to give me back to the original form, which is, you know, around 1, right? Then iPhone, what were you saying?
Sir, don't worry.
So you change the name to Chelsea now.
What is me?
But somebody said, somebody by the name of iPhone raised their hand. I wonder if it was you.
It's me, sir.
Oh. All right, here we go, guys. If this meeting runs out of time, I have 10 minutes remaining. Just go ahead and re-click on the link, and we will proceed again. All right. So clearly, guys, we see how density operates here, and if the object is much denser, we expect that it's going to sink, right? Now, when you look at a boat, clearly a boat is somewhat confusing because a boat floating on water. Typically, a boat is made up of metal. And let me go back to the simulation here and drop a piece of aluminum inside of the water, right? I place the aluminum inside of the water and I realize that, hey, you know, this aluminum, it does sink, right? So let's look at a boat now. A boat is made up of metal.
I'm hearing it.
Some boats are made up of metal, not all, right? But typically, look at this big cruise ship here. We expect that this big cruise ship is going to be made of metal. But why is it still floating? Can somebody answer that question? Anybody? Somebody? Pingy, I know you like to talk. Why do you think this boat is still afloat in water? And it is made up of metal.
Sir, I don't understand anything. Because I just came.
Oh, you just came?
Yes,
all right.
sir.
Yes, sir. What are you doing? I just joined.
So why you just join, man?
Sir, because I'm doing something.
No, man, you're not supposed to do nothing, no, man. It's class time now. You understand?
Sir.
Don't make it a habit to come to my class late because you're not gonna waste my time to reiterate all of this information. You understand? Class starts 9 o'clock, and we expect to kickstart at that time, right? So somebody else who were here at the beginning, all right? Explain to me.
Sir, can I try?
Go ahead, please.
Well, I heard like on boats, sir, they have like this like air system at the bottom. So they put air at the bottom of the boat. I'm correct?
I'm listening to you. All right? Don't get ahead of yourself.
Oh, okay. So they have like this air system at the bottom of the boat. So like the air system, like it helps with the floating mechanism for the boat to float on top of the water and not sink.
Nice.
Am I correct?
That's a good point you have raised. I like that point. So you're actually learning some stuff. Now let's compare something, guys. Air, I mean the density of air. Just to clarify that what she said, density of air versus the density of water. Let's just see the value because there should be a value. All right. I hope it's not going to be confusing. But what I'm getting at, because we know air is less compact, right? Can we agree on that in terms of, you know, the states of matter? Can we agree? Oh, here is it. So I have it here. So here is gas, right? Gas, well, you have different types of gas. Well, let's talk about oxygen, so to speak. Right? This is the density that oxygen has. Whereas for carbon dioxide, this is the density 1.96 kilograms per meters cube. Versus now liquid, we're talking about water. So the boat is in water. And now if you look at these values, the density of water is 1,000 kilograms per meters cube. Clearly we can see that this density value far outweighs the density of gas. And we can look at it from our molecules, how they behave within inside of a container. So imagine you have a boat. All right, well, I'm just stop if I'm writing on my screen because I don't want it to mess it up. Right? Imagine you have a boat that is made up of metal, right? So metal is, as we know, it's far greater in terms of density. But now we as scientists have, you know, utilized all of these things to say, all right, you know what, I'm going to cheat the system. Even though metal is much denser, I can now incorporate air within inside of this thing, right? Which is of a less density in terms of when you compare it to water. And now with that now, it's going to allow, you know, metals such as boats. Now we have to understand that this thing has to be compressed in a sense where it has to be tight sealed because you don't want your air to be letting out. You understand? So once there is a puncture in your foot, you're going to lose the air that is inside of it that is helping it to keep it afloat, right? And you know, you're going to also allow the thing to sink because, you know, obviously metal is much heavier. Cool. So Robin, Robino, rather, you understand what's going on?
Yes, sir.
Anybody else? Let me hear what you have to say. Are we getting it?
Yes, sir.
Freeman, talk to me quickly.
Yes, sir, understand.
Norman, what you say?
That's not true.
Norman, talk to me.
Sir?
What, you're not paying attention, man.
Sir, me just come a while ago, sir.
Regine, why you coming so late to my class?
Sir, me never knew, me couldn't find something, sir.
Listen to me, man. Don't get me upset, boy. King, talk to me.
Sir,
Go ahead.
Yes,
Yes,
sir.
sir.
no.
All right. So yeah, I mean, if you see something that you need to write, right, then sure, go ahead and do that. Right? Because you definitely need to know the definition of what of density, right? And you also need to know, like, you know, what is the density of water. Now, we won't go into too much of a greater depth in terms of calculating density, seeing that the syllabus doesn't require it, right? But we're just skimming the surface to say that, hey, you know, typically, right, we know that when you have an object in water, it's going to be the force of weight acting down on the object, right? Then now, we also expect that, you know, if it's in water or air, there is another force called upthrust that is going to push itself upwards. You understand? So we know that information, but clearly there's another aspect that we need to consider, and that is that is as a result of, you know, whether the object is dense or less dense. You understand? To consider whether if it's going to float or sink. You understand? Because there are situations, because if you look at the simulation, we see where that, you know, some of the objects sank, right? While some were able to float. And we have to put into context density as well, not just only the forces that are acting, but also the density of the object, so to speak. So you can go ahead and make a note of what you need to make a note of, right? Before we proceed to another aspect of the syllabus or the guide that we're working with. But if there are any questions so far, go ahead, pose your questions. Anything you want to clarify, go ahead and let me do that right now before we move on. No, I have less than 1 minute remaining. So once it closes off, just re-click on the same link and we'll access the class again. Grant, I'm coming back to you. Because I want you to talk. All right, so as this one finishes, just start back over so we can just proceed again, right? Because 1 or 2 persons still don't understand, but we're coming back to that.